So let's take care of two more problems. First, let's change this tangent to sine over cosine. And then leave the rest of the expression the same. Next, we look up in our numerator and we see that I've got a fraction minus something else. So let's change that second term into a fraction and then get common denominators. Common denominator is going to need to be cosine of x. So multiply that second fraction with cosine of x on the bottom and on the top. When we do that, a new fraction, our entire expression will look like this. It's going to be a cosine squared up top, and then a cosine on the bottom, all over sine squared of x. Now that we've got common denominators, we can subtract those two fractions. So it's all going to have that sine squared on the bottom. These two fractions will have our common denominator. And then up top is going to be sine of x minus sine of x cosine squared x. Now I see that these two terms have a common factor of sine of x. So I think at this point we should factor out that sine of x. I think you'll see why in the next step. Do that. Notice what's left behind. What's left behind, finish writing this out. What's left behind is 1 minus cosine squared of x, and that's one of our Pythagorean identities. So sub in place of that 1 minus cosine squared of x, sine squared of x. We'll have that sine of x. Have this sine of x here times the sine squared that we subbed in right there over cosine of x all over sine squared. Alright, so then let's use our keep, change, flip. Keep the first fraction, change this division bar to multiplication, and then flip the denominator. Now when we multiply these two fractions together, we see we have a common factor, which we can cancel out. Multiply across the top, we've got sine of x, and across the bottom we have cosine of x. And that is one of our quotient identities, which is tangent of x. And if we go back up to our problem, we see that's exactly what we wanted to show. And so we are done with that one. Next up. This one I'm going to sine and cosine out as well. When we do that, we're going to have a bunch of fractions on the left side. But we'll be able to handle it. Now, we've got these two fractions, and what we often do when we have two fractions being added together is we try to find common denominators. That common denominator is going to be found, as usual, by multiplying those two denominators together. So our common denominator is going to be sine of x cosine of x. To make that happen, we need to multiply this one by cosine over cosine, and the other fraction by sine over sine. The result, way up top, we're still going to have 1 over sine of x. This first fraction will be cosine squared all over cosine times sine. Second fraction will be sine squared over cosine times sine. Now that we've got common denominators, we'll add those together. Still have a 1 over sine of x way up top. Now it's pretty convenient what happens really when we get those common denominators and add the two fractions together. So when we do, this cosine squared plus sine squared is one of our Pythagorean identities, because that equals 1. And so this equals 1 over sine of x, big fraction bar, over 1 over cosine times sine. Now we're going to keep, change, flip. Keep, change, division to multiply, and then flip this fraction all over 1. Sines cancel, and we have 1 times cosine over 1 times 1. Cosine of x over 1 is cosine of x, which is exactly what we wanted to prove. So I'll leave these last two. We can possibly do them during in class tomorrow, but that's good for now. See you in class.